This is where we finished off last time, and I'm just going to go over it again. This is the ArrayIterator. Now I will say, actually, if you go and you download these iterator classes, the ArrayIterator and LinkedIterator, which are included at the end of the topic, they are their own standalone classes. But typically, maybe typically isn't the right word, but often these are written like private inner classes, similar to like how the nodes are in a lot of the link structures. But for our purposes, to keep things simple, for lack of a better term, we'll just have them as their standalone classes. But if you're looking at code and you see these iterators implemented as private inner classes, that's normal. All right, so ArrayIterator. All this is doing is defining what the stupid little object does, the iterator object. The iterator object is just this little robot that goes and puts its finger on each element in some collection. That's all it's doing. That's it. And what we do is we implement the Iterator interface, and with that interface, that guarantees that the thing we're writing has a couple of important methods. The ones that we really care about are next and has next. So for an ArrayIterator, what are we going to have? Well, let's have a couple of fields. We're going to have the collection itself that we're iterating over. So if this is an ArrayIterator, it's going to be an iterator for some array. So let's have reference to the array that we're actually going to be iterating over. Size, which is the number of elements in that array that we care about. Because remember, arrays could be size 1,000,000, but really maybe there's only 7 things in there that we care about. So size might be 7. And index is going to be the current index. The index that the iterator is currently sitting at. And that index is going to be what changes. The constructor is relatively simple. It takes the array and the size. It assigns the field elements, that's the array size. And index is set to 0 because it starts at index 0. We could write an iterator. We could have it maybe call it like a reverse iterator. That just goes in reverse order. That's fine. We could do that. It's not that typical, but we could. I shouldn't say it's not that typical. It's not what we're doing here. We're going to start at the beginning and go to the end. And all this here is doing is this is just a little bit of like bounds checking. If I ever give you a size, if I give you an array of size 7 or array of size 10 and say its size is 17, that's not going to work, is it? The number of elements in an array cannot exceed the capacity of that array. So if anyone did that, that means they're using this wrong. So just throw an exception. Here I'm throwing an illegal argument exception. Kind of makes sense in this context. And it's got a message, size exceeds array length. There. That's just a bounds check. Then we have has next and next. Has next is simple. It is a Boolean it's a function that's going to return a method that's going to return a Boolean, whether or not there exists more things for this iterator to return. If the size, if the index is less than the size, yeah, there's more there. Then next. And this kind of hits to someone brought up a question, you brought up the question last time, and it kind of comes down to people maybe being a little thrown off by the name of this method called next. We always think next is like the next thing. But before we've asked the iterator to do anything, when I say next, it's going to return the element at the beginning. Give me the next thing. Well, the next thing happens to be the first thing. So next, first is going to say, okay, is there a next? If there isn't, throw an exception. What's the exception? No such element exception. Great. Otherwise, get the element at the index it's currently at the beginning. It's going to be index 0. Get the element, increase the index, and return the element when you're done. By increasing the index, so this next is doing 2 things. The little robot is getting the data it's going to return. It takes a step to the next element by increasing index and returning the value. So next not only returns the element, but also prepares itself for the next time it's called. So that's the ArrayIterator. This is just defining the stupid little ArrayIterator object. It's just an object whose only purpose in life is to iterate over an array. That's it. That's all it's ever going to do. That's it. Consider the ArrayIterator has reference to the, yeah, and then this is just a warning. This ArrayIterator does have reference to the array it's iterating over. Okay? Maybe when we see this actually getting used, it'll be a little clearer. But it does have reference to the collection it's iterating over. So we got to be careful to make sure this iterator is not modifying any of the contents of that array. Otherwise, we're going to have a nightmare. All it does is observe and iterates over the collection, but leaves it alone, doesn't modify anything. All it does is return the elements in order so we can iterate over that collection. Any questions? Now, the way we would use this, I think I've got an example up here, is let's say I ask something that is iterable, which we'll see in a moment, to give me its iterator. So let's say on line 1, I'm creating an iterator called Iterator. Great. This iterator reference variable is going to be referencing something like this ArrayIterator. And this iterator has 2 important methods. Has next and next. So here's how I iterate over a collection using this iterator. I can say, okay, iterator, does there exist a next thing? Yes or no? Yeah? All right. Get it. Ask the question again. This loop will iterate over the whole collection that the iterator is for. That's it. That's how we do it. There's no need for a for loop for I equals 0, I less than the length or whatever, and I plus plus. No. That's how we do it. So this iterator could be an ArrayIterator, and we know that has next and next work. Let's go look at how we might implement a linked iterator. We did it for an array, so that would work for things like our array stack, array queue, array bag, array-based bag, so maybe the index bag or the sorted bag. But what about the linked implementation? What about a linked bag that we could make? What about a linked stack, linked queue? Well, here's how we could define an iterator for a linked collection. I'm only going to have one field, current. It's a node. It's a reference to a node of type T, whatever. And this constructor only takes reference to the node presumably at the head of this linked structure. So if I have a queue, I give it reference to the front. So this current is just, it's starting at the beginning of that collection, and it's ready to go. Has next is, does current reference null or not? If it does reference null, there's nothing. If it doesn't reference null, well then it does have a next. And then next, well, if it doesn't have a next, throw an exception. Otherwise, get current's data. Current, you reference current's next. That's the step. And then return the data. That's it. It didn't modify anything in there. All it's doing is getting the data it wants to return and making that step. But it's a linked structure. So with the array, to do the step, we just incremented that index. With a linked structure, well, we have to do it a little differently. We say current, what's your next? Well, that's reference to another node, and just have current reference that subsequent node. If you're scratching your head thinking, this seems really simple, it is. It's supposed to be. It's a stupid little object that just says, has next and next. And again, imagine I go up here. It's the same thing. Imagine this iterator line 1 is referencing some linked iterator. I know over here it says arbitrary iterable thing.iterator. Ignore that for a moment. Just this will be referencing some iterator object, whether it's an ArrayIterator or a linked iterator. It's an iterator. And that iterator has next and next. This code is going to work exactly the same way, regardless of if the thing on the right-hand side of line 1 is an ArrayIterator or linked iterator. Does it have a next thing? Yes or no? If it does, get the next. Does it have a next thing? If it does, get the next. And so on and so on and so on. That's it. So now, you should be getting a sense that, okay, regardless of if I have an array or a linked structure ultimately as a container for the data in my collection, I can iterate, I can loop over all of those things the exact same way with the iterator, with has next and next. It's the same regardless. Before, with the array, I would use a for loop with an I, 0 to index or length or whatever. With the link structure, it would always be like, well, current isn't null. Basically what we saw in the iterator thing. There we go. So there's our linked iterator. Oh yeah, here's a note. If I have a collection that I'm writing, like let's say the linked queue, and I made my node class an inner class, a private one that existed within the linked queue class, not a standalone class, this iterator would also need to be a private internal class as well, just as a warning. So, if you were to go back and look at the code in the sorted bag or the linked bag, which I know everyone who was at lab did, and when you downloaded like the array sorted bag, for example, raise your hand if you had your thing yelling at you about like, well, ArrayIterator is not defined. What's ArrayIterator? Of course, yeah, it's because you never implemented it. I told you, well, just go download it, add it to shut it up. But now I showed you how we actually implement it. If you go look at the code that you can download at the end of this topic, yeah, it'll be exactly what I showed you. So now, for that method, iterator, that existed in the bags, because regardless of what type of bag it was, bag implemented iterable, or extended iterable, I can't remember. It's something iterable. Meaning, it had to include this iterator method. And the iterator method must return some iterator object. If I have an array sorted bag, or an array linked, or an array indexed bag, regardless, this code right here is all I would need for that iterator method. Return a new ArrayIterator that takes bag, that was the array containing the elements, and size. Create a new iterator. Think of it like this. This ArrayIterator is a stupid little robot. I'm the array sorted bag. And you want my iterator. So here's what I do. You say, hey, give me an iterator for yourself. I go, okay, great. I'm going to make this robot, start it here at the beginning, and I'll give you a reference to that robot, and you're good to go. So if you call this iterator method, I return this iterator that you can then, if I go back up here again, do exactly this. Imagine this is some array sorted bag. .iterator. It returns the iterator, and now I can iterate over it. Maybe it was a linked queue where we implemented an iterator. Great, it returns a linked iterator. It's kind of hidden behind that method. I don't give a shit which type of iterator it is. It's an iterator. That's all I care about. So this returns the iterator. So the iterator interface is for objects, those stupid little objects that are just going to iterate over the collection. It's its only purpose in life. The iterable one is for a collection. A collection is iterable when it returns an iterator for itself. So if I am the collection, like the array sorted bag, I must have that iterator method that returns an iterator. And in order to do that, I make an iterator object. So the iterator object iterates. If I'm iterable, I return an iterator that will be used to iterate. Clear? Cool. All right, collection. If I had a linked sorted bag, this is what I would do. A linked iterator, assuming it exists, that class that we just wrote. Both versions of the sorted bag return an iterator. And here we go. Let me put it this way. When you look at this code right here, what type of iterator is this using? Is it using an ArrayIterator or a LinkedIterator? I'm seeing people go, and you're right, you don't know. Does it matter? No. All that matters is I have an iterator, I can ask it if it has a next thing, and I can ask it to get its next thing. It doesn't matter to me if it's an ArrayIterator or a LinkedIterator. All that matters is that they're both iterators, which they are because they implemented that iterator interface. Meaning they must have the next and has next. So when you look at this code right here, you don't know what the actual type of iterator is. You don't know if this is an array-based bag or a linked-based bag, but it doesn't matter. It has no impact on how I actually iterate over that collection. I iterate over that collection, whether it's an array-based one or a link-based one, the exact same way, which is nice. I now have a common, uniform way to iterate over a collection regardless of the underlying container. This is amazing. And this becomes very powerful, which we'll see in the next lab. But consider this toString for some collection. What do I have a string builder. I create an iterator by doing this.iterator. So I ask, hey, call my iterator method that returns an iterator for this collection. Well, iterator has next. Builder.append the iterators next. Builder.append a comma space, just because I want to format my collection with commas between each element. And then at the end, return builder.toString. If we go back and we look at, do I even have it open? I do not. Here, let's open this real quick. If I could go and quickly look at the linked stack and the array stack. No, let's think the queues. The linked queue and the array queue, if IntelliJ will ever open. We'll see how the toStrings were implemented before. Uh-oh, it's opening up the solutions to assignments. Oh no. Uh-oh. 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 So here, let's go here quickly. Let me ask you again. Is that an array-based container or a link-based container? It doesn't matter. You don't know? Exactly. I don't know. But it doesn't matter. All that matters is, well, I'm iterating over the collection. I don't give a shit what type of collection it is. I'm iterating over it. Which is amazing. Oh, sadly, this is very unhelpful. I know. This window.
If you're going to make a mistake like this, you got to make it so it benefits us.
Sorry.
Yeah.
I try my best not to make those mistakes.
Okay, well.
So let's go look at an array queue and the linked queue. So before, here's the toString for the linked queue, and here's the toString for the array queue. They're different because the way you loop over an array very straightforwardly is different than the way you loop over the link structure. But if you had an iterator, you could replace with this. You could replace those with this, and it will work. My toString can be the exact same code for the array-based one and the linked-based one. The code could be identical. That's nice. We like that. We don't need to tune our implementations anymore because we've abstracted the way we iterate over things to a level of just saying next and has next. I didn't need to go beyond that next and has next. If you go open the hood on those iterators, yeah, the specific implementation has to deal with the fact that it's an array or a link structure. But we hid that behind that abstraction level of just next and has next, which is nice. Yeah. Now, iterable interface. The iterator interface is used for creating an iterator object. Yes?
Are there any downsides to doing it that way?
No. We love it. We love it this way. In fact, there's so many benefits to doing it this way that you're going to laugh at the way we used to do it. The way we used to do it was terrible. But, well, we did it that way because I didn't really want to throw you into the deep end that bad at the beginning of the semester with, hey, figure out iterators. What? What's Java, right? All right. When you make, okay, if making a class that is to be iterated over, I just said this before, that class will implement iterable. So iterator is for the little robots that do the iterating. Iterable is for a collection that you want to be iterable. There's a difference. Within the iterable interface, there is one abstract method, iterator. If this interface is implemented correctly, the collection is guaranteed to be iterable, which is nice. Now, I just showed you the way that we use an iterator, kind of like the old-fashioned way. I say that kind of, well, give me a second. Where you create an iterator object, you ask if the iterator object has next, and if it does, within the loop, we get the next thing, and you repeat. But Java came along with what they call the enhanced for loop. This was a long time ago, but you know, it's new. The enhanced for loop. And this is actually what you're used to in Python. The for loop used like this is what you're used to in Python, where you were used to in Python. For each thing in some collection of things. In Python, that collection of things, often like a list, right? That list is iterable. For each thing in a collection of things. If you made your collection iterable, you can use enhanced for loops on those collections. You can say, for each thing in my collection of things. The syntax is a little different, though, from Python. It's still a for loop, but it's a different kind of for loop. It's the enhanced for loop, the for each. For, so I've got type, ref var, colon, iterable thing. If we were to think back to Python, you would say for x in my bag. But in Java, for, we need the parenthesis. We need to specify the type of the reference variable. X is the thing. Colon instead of in. Why? Because. And my bag is the iterable thing, the collection of things. Yes?
Can you use generic types in the for each loop?
Yes, but one second. Like this right here?
Yeah.
Yep. So, this enhanced for loop becomes an even nicer way of iterating over the collection. The way I just showed you of calling iterator, having it return an iterator object, asking the iterator object, has next and next, entirely fine. But when it's iterable, it allows you to even use these enhanced for loop. So I could actually do that same toString I did a moment ago, this one, where I created the iterator object by asking the thing to call the iterator method, which returned an iterator. If the iterator has next, get the iterators next. I can replace all that with the enhanced for loop. For element in this. Now, the this is probably throwing you off. Maybe it's not, maybe it is. If it is, let me put it this way. Just create a new class. arrays are iterable. So I can use an enhanced for loop just like this. Now, I just have a whole bunch of zeros here, 200 of them in fact, because by default, when you create an array of size 200, Java's going to put zeros in there, or whatever the default value is for that type. What's it mad about here? Oh, yeah. So here, thing is a reference variable to each thing in that collection, and my array is the collection I want to iterate over. But really, it's not the collection I want to iterate over. It's a reference to the collection I want to iterate over, right? Because everything's always a reference variable. That's what the this is. Consider for the fact that this toString method is within the queue class. A linked queue, an array queue, whatever, some queue implementation. And it's that queue that's iterable. So this is the toString for the queue. So I have a linked queue. And this is toString for that linked queue. And I want to use this enhanced for loop. So for each element in the collection of things, or a reference variable to the collection of things. But it's the queue that's iterable. So it is the instance of the object itself that's iterable. And what is that magic keyword we use as a reference variable to reference the instance? This. Similar to self in Python. This. So this class, the linked queue, is iterable. So I can use this, and it'll work just fine. So in the example I just showed you, it was an array reference variable. Here, it's a reference variable to itself, because the linked queue is iterable. So just, if you're wondering, well, what's really the difference under the hood? This enhanced for loop is just an example of syntactic sugar. And remember when I say syntactic sugar, it's kind of this weird phrase programmers use to mean like, look, it doesn't mean anything more than the other. It's a nicer way to write the code to do that thing. So I could do it this way, but it's the same. These are equivalent. This is just arguably a nicer way to use the iterator instead of calling the method to have a reference variable to an instance, using a while loop, keep asking if it has a next, and then calling next. Yeah?
Do we have to implement iterator into the class so that we can use that loop?
So you would have to have an iterator for the underlying collection defined. We're only looked at array-based ones and link-based ones, so yeah, you could have them. You just download them, add them to your project. And then the collection that you want to be iterable has to implement the iterable interface.
Okay.
And that's when we can use it. Because if you implement the iterable interface, that means that that class must have an iterator method that returns an iterator. And if you implemented it correctly, this will work. Now, just because you implemented the interface doesn't guarantee you implemented it correctly, and then it could bug out. But based on if you did everything right, this will work just fine. But it must be defined as iterable. Otherwise, Java's going to be like, I can't do that. But when you do implement it, Java can guarantee that these methods exist, so it should be good. Cool. Any questions? So, we've got, I don't know if anyone's noticed this, but we've got a big problem with our stack and queue implementations. A huge problem. If you go and you look at the equals methods, so here's the array stack equals method. And, we got a bit of a problem. because I could have a linked stack. And if I have a reference variable to some stack, should it be possible for an array stack and a linked stack to be considered equal? They're both stacks. Let me ask this. What does it mean for two stacks to be equivalent?
The contents of the stack are the same.
Exactly.
The order is the same.
Yeah, the contents and the order. Yeah, I guess we could combine those there.
It'd be the same size.
Implicitly, yeah. If the contents are the contents are the same and they exist in the same order,
Yeah.
presumably they have the same size. So that's what it should mean for stacks to be equal. And with that, it doesn't really matter if I have an array-based stack or a linked-based stack. Based on that definition, I should be able to have two stacks being equal regardless of the underlying implementation. But when you look at the code we used, look at what line is that? 103. It checks the class of this object and the other object. And if the classes aren't the same, it returns false. Meaning, if I have an array stack and you have a linked stack, it's not going to work. It would be better if I had an equals, allow for a comparison between a linked stack and an array stack. But the problem was, I couldn't do that. I can't, with the implementation of the stack and the queue, I can't actually compare them. Because, when in order to compare them, I would, on line 106, I have a reference variable called that is referencing an array stack. First thing I'm going to want to change is what was this? Is this the linked stack implementation? Yeah, this is the linked stacks equals as well. So, is that quite right? What I'm going to want to do is I'm going to want to have a reference variable for a stack. Not an array stack, not a linked stack. I want it to be a stack. And if it's a stack, all I know is that it's got push, pop, peek, is empty, size. But I don't really have a way to compare the things. But with iterators, I do. If I have iterators, I can get an iterator for this stack, an iterator for that stack, and iterate over the two collections and check for equality as we go. Because now with the iterators, I can iterate over the collection, and the way I iterate over them doesn't depend on the implementation. I don't need to know if it's an array stack. I don't need to know if it's a linked stack. All I need to know is that it's a stack that's iterable, and I can get an iterator for it. Now, this won't work with the stacks we wrote and the queues we wrote because they didn't implement iterable. I can't iterate over those collections. But if I were to go back, update those interfaces to implement iterable, implement the iterator method for the stacks, and queues similarly, then I could suddenly start checking equality between the types, between the specific implementation types, where I couldn't before, which is pretty cool. Anyways. Yes?
If you go back over to that code, so the while loop stops when this iterator has next, but what if the contents of the stack in that exceed and keep going.
This checks that.
Oh, that would check.
Yep, good, very good observation, right? If I have a stack with 7 things and a stack with 10 things, what if the first 7 are equal, but then this one has 3 more? And suddenly it doesn't do, well, the first check is, okay, are they the same size? If they are, then go ahead and do the comparison. If they're not, don't even bother, they're not the same. But good catch. But we do address that. If the sizes are different, they're not equal. If I didn't have that check, that bug could pop up. All right, exceptions. What I'm about to talk about probably isn't going to be overly enlightening because you've been using exceptions a lot already. But we're going to talk a little bit about exceptions, perhaps slightly more formally than we did before. Exceptions were kind of this thing that we use that you kind of had to fill in the blanks on, but let's talk about exceptions. So exceptions provide a logical way. So I should start by saying there are a lot of programmers that really don't like exceptions. They feel as if exceptions are a type of side effect, and side effects are problematic, and we don't like side effects. But for better or worse, they exist, we use them, exceptions. So, exceptions give us a couple of things. They provide a way to logically separate our code from the general, typical working case, and what happens when something funny happens, when something exceptional happens. So there's this nice separation of what to do normally, what to do in the atypical situation. So there's a separation there, which is nice because we get the separation of the code, so we don't have to jump around as much. What else? It makes it easy to package an issue and propagate it to where it would need to get addressed. Because if, let's say I've got a function that calls a method, that calls a method, that calls a function, that calls a method, that calls, and so on and so on and so on. And one of them throws an exception. And the exception gets propagated up each of that calls until a certain spot where it's going to get addressed. And if it doesn't get addressed, it just keeps getting propagated until it's thrown at you, and that's why you see your program crash where you see an exception. But it gives us a way of propagating exceptions up the call stack. And the call stack is an idea that we're going to talk about more in the next topic, I believe. So it can be managed in the desired spot. And it also allows for differentiating between exception types and how to deal with them accordingly. Because I might have a method that can raise an exception for multiple reasons. And if you actually go and look at the array indexed bag, I believe there's a couple of methods in there that can actually raise an exception, raise 2 different types of exceptions. I'm trying to remember the example, but you might have what happens if you specify an index that's too big? Well, you get an array index out of bounds exception. What happens if the element doesn't exist? Well, you get a element doesn't exist, no such element exception or whatever. So the different exceptional situation could result in different types of exceptions, which is also kind of nice. It gives us a way to differentiate between them. And exceptions do exist in the Java class hierarchy. They are all a subtype of object. And under the object, there's a subtype called throwable. And under that, you have errors and exceptions. Errors are things we're not going to really worry about because errors are catastrophic problems that you had nothing to do with. If you ever see your code have it throw an error, something really bad has happened. Something's wrong with your computer. It's not Java, it's not you, something funny happened. But you have exceptions. Those are the ones that we programmers are more comfortable with. And within them, we have 2 different types. We have runtime exceptions and other exceptions. Some exceptions are things that you're supposed to deal with. Some exceptions are things that someone just used the code wrong, but we'll dig a little deeper into that in a moment. So errors. In Java, there are 2 classes of throwable objects. Throwable objects are the ones that we use when we use the throw keyword. Errors are one of the two throwable. Errors are typically unrecoverable situation. There's nothing, you're not going to want to catch an error because there's nothing you can do to address that problem. Typically they're not caught or handled. Errors are regarded as unchecked for the purpose of compile time. Don't worry about that. There's something like an out-of-memory exception. Imagine your program runs out of memory. What are you going to do about that? You can't really do anything about it, right? Your program's running and it just ran out of memory. You can't. What are you going to write in your code to address that situation? No, you can't. If the JVM runs out of memory, there's nothing the program can do to resolve the situation, for example. That's really all we're going to talk about with the errors. Just they exist. You're unlikely to get them, and if you do, don't feel bad about yourself. It's not your problem. It's probably not your fault. So exceptions. Several methods so far have thrown exceptions. So here's the remove, for example. The remove method from the array sorted bag. Remove may throw an exception when trying to remove from an empty bag, or if the element does not exist in the bag. So there are two different exceptions that can be thrown here. Interestingly enough, they have the same type. Both exceptions are no such element exception. They have different messages. And when these exceptions are thrown depends on different situations. If you remove from an empty bag, and you're going to raise an exception that tells us, well, there's an empty bag. You can't remove from an empty bag. Or maybe you're trying to remove an element that doesn't exist in that bag. Okay, well, we'll raise an exception again, but we have a different message that we pass because something went wrong in a different way. You see? So this example can raise or throw two different exceptions depending on what's gone funny. Is that clear? Is it empty? All right, well, we got a problem. It's not empty, but the element doesn't exist. Okay, we got a problem. All right, okay, although the remove method is throwing two possible exceptions of the same type, oh yeah, when a method throws an exception, they don't need to be the same type. If you have a method that can be throwing exceptions, they could be a variety of different types. You could have like a no such element exception, maybe an illegal arguments exception, a whole bunch of different types of exceptions. They don't have to match. They just happen to match in this example. A no such element exception is a type, it's a runtime exception. It's a subclass of a runtime exception. Under exception, we have like everything else and runtime exceptions. If it's an unchecked exception, so this method does not need to include, it's an unchecked exception, meaning this method doesn't need to include a throws no such element. Okay. If you have checked and unchecked exceptions, there are some exceptions that you want to force people to look for to make sure that you're using it right, and some you don't really care. Like with file I/O. Remember how with file I/O, the very beginning of or even reading from like a console, we had to write that, we had two options. We had to write it in a try-catch block. Remember that way at the beginning of the semester when you were doing that I/O? It had to be in a try-catch block, or you could just put throws in the main method to make it shut up, right? Those are exceptions that have to be checked. You must write your code in such a way that guarantees that you're addressing the situation, because something funny could happen. But then you have these unchecked exceptions, like these runtime exceptions, which means like, okay, no, you as a programmer just effed up. This is your problem. Deal with it. It's not like this code, something funny could happen that you have to address. It's, no, you indexed this array wrong. FYI. Not something you need to like memorize hardcore, really understand right now, but be aware there's technically different types. And if you want to guarantee that someone's checking the exception, you can add the throws keyword to the signature. So you would say public boolean remove throws no such element exception. But we wouldn't do that here because it's not something we would care for someone to force them to check. All right. The motivation for using exception here is if someone tries to remove from an empty bag, or if the element does not exist within the bag, what should happen? Well, this is going to be situational. Like everything we've talked about with exceptions before. Perhaps this means some critical error happened in the program and it needs to stop immediately. Or maybe it's not that big of a deal and the program can just ignore it and carry on. Or maybe someone just used it wrong and so it has a bug and it crashes your program, whatever. It's situational. But this is the whole motivation of exceptions, right? Something funny happened. And I don't really know what you want to do about it. If you called my method that throws an exception, and something funny happened, what do I want the code to do if that funny thing happened? I don't know. But what I can do is I can throw that exception, give it back to you, and you can check to see the type of exception and deal with that situation accordingly. The messages, that's just the strings you put inside the in the parentheses when creating an exception. Provide some context of what went wrong, like here. If you've got the two different exception types, no such element exception, no such element exception, they're both no such element exceptions. But the message here gives a little bit more details. Do you need help? No? Just want to walk through my lecture hall? Weird. We're not that late. Look at that. So no such element exception gets thrown. Well, why? Well, the message tells you. Empty bag, oh, because it was empty. Or if you get the string version of the element you're looking for, well, it's telling you basically the thing that you're looking for to remove just doesn't exist. So it returns the string form of the element you're trying to remove as the exception. So the message gives context for what was gone, what went funny. Yeah. We like to add the messages because it gives details. Like every time, like if you go and access an array, imagine I'm doing 1 billion array accesses, and my program crashes because it says array index out of bounds. Okay. But if it says array index out of bounds 17, I go, oh, I was trying to access index 17 and it doesn't exist. So the message is just, it's nice. It gives you additional details. And perhaps this is where we stop for now. Any last questions?